Dear second prep, Assalamu alaikum wa rahmatullah wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Algebra Unit 3, Lesson 1. The lesson is called the probability. This is, inshallah, will be the last lesson in the algebra in this term. Okay, what is the probability? Actually, we have studied the probability many times. We studied in the first prep, 6th primary, and so on. Okay, what is the probability? The probability is a branch in mathematics in which we use to describe the event in form of a number, or this branch change the event in form of number to help us to study or to expect what is the next step. For example, if we are going to start a new business, so we use the probability to expect what is the successfulness of this business in this area. Or another example, we use a probability to expect what will happen in the weather in the next day or in the next days, and so on, according to the data we have related to this weather, okay, from days like this. Okay, let's start the lesson. In the probability, we have actually two types of the probability. We have experimental probability, and we have studied this one in the first prep, and the most important one, the theoretical probability. The theoretical probability that we expect, or it is called the expected probability. For example, if we flip a coin 100 times, so we expect that the head comes 50 times and the tail comes 50 times. This is theoretically without doing the experiment. Okay, so we can say that if we have an experiment of tossing a piece of coin and we observe the appearance in the upper face, because we know that the coin included head or tail, so the appearance of a head equal what? The appearance of a head, or the probability of appearance of a head, equal 1 out of 2, or equal 0.5 or 0.50. Also the probability of appearance of a tail equal, we have one tail out of two tails out of two faces, so it is 1 over 2 or 0.5. So in the theoretical probability, we expect what will happen without doing the experiment. Okay, now let's remember some definitions related to the probability. This definition we already studied before many times. First, I have to remind you what is the random experiment. The random experiment, this is experiment in which we can determine all its possible outcomes, or we know all its possible outcomes. Again, an experiment in which we can specify all its possible outcomes before carrying it out, but we can't determine certainly which of them will occur. For example, I have now flip a coin. Okay, the coin included head or tail. I know actually, okay, all the possible outcomes, head or tail, but I don't know exactly what will happen, head or tail. Okay, now we have another definition called sample space. Okay, any experiment included formed from elements. These elements recorded inside a set, this set called sample space. So the sample space is a set of all possible outcomes of a random experiment, and it is denoted by S. For example, when we toss a piece of coin once, and then the sample space is what? Okay, the coin included head or tail. So the sample space here is a set of H or T, or head or tail. Another example, when we roll a fair die or dice, and observe the appearance of a number on the upper face. Okay, the die included 6 faces numbered from 1 to 6. So the sample space in that case equal set of 1, 2, 3, 4, 5, and 6. Okay, so the random experiment, and I don't know what exactly will happen, but I know all the outcomes. The sample space is a set, included all outcomes. Okay, and now I'm going to explain or remind you with the event. Okay, what is the event? The event is the most important item inside the probability. Actually, we study the probability because of the event. What is the event? The event is the condition we are going to study, or we can say that the event is a subset of a sample space. Example. Okay, if A is the event of appearance of an odd number, okay, when rolling a fair die once and observing the upper face number on the upper face. Okay, now the sample space included numbers from 1 to 6, 1, 2, 3, 4, 5, and 6. Okay, this is the sample space, all outcomes. But here I have event, its name is A. A means, okay, expected that the appearance is an odd number. Okay, then A included 1, 3, or 5. Okay, again, A equal 1, 3, or 5. The event written in form of a set, and this set is a subset from the sample space because the sample space included 1, 2, 3, 4, 5, 6. So A subset of sample space. Okay. Another example, if B is the event of appearance of an even number, okay, when rolling a fair die once, okay, then B equal what? B is the even numbers, so B equal 2, 4, and 6. B also subset from the sample space, okay? Now, what is the probability or the theoretical probability? The theoretical probability equal the number of elements of the event over the number of elements of the sample space. Again, the number of elements of the event over the number of elements of the sample space. For example, if I need to evaluate the probability of the event A, it is equal, okay, equal 3 out of 6. Why 3? Because A included 1, 2, 3 numbers, and the sample space included 6 faces. So I have 3 over 6, which is 1 over 2. Another example, if I need to evaluate the probability of the event B, I have here 1, 2, 3 elements out of 6 elements. So it is 3 over 6, which is 1 over 2. So I can abbreviate the number of elements of the event by NA. N means number of elements of A, and the number of elements of the sample space, NS. N here means the number of elements of S. So finally, this is the main condition or the main rule that I'm going to use in the following. The probability equal the number of elements of the event over the total number. Okay, actually I don't need you to memorize the definitions. You don't need to memorize the definition. Okay, the questions comes, okay, to ask you about how to evaluate the probability, not to complete the definitions. Okay, now let's study example 1. Okay, in this example we have a throwing a fair die and observing the upper face. Complete the following. Number 1, the probability of appearance of number greater than 2. First, I'm going to write the sample space S. S equal set of 1, 2, 3, 4, 5, 6, and close the set from 1 to 6. The appearance of number greater than 2. I'm going to call the first event A. So A equal set of. greater than 2, so it is 3, 4, 5, and 6. Okay, now to evaluate the probability. The probability equals the number of elements of A over the number of elements of S. So it is 1, 2, 3, 4 over 6. 4 over 6 equals 2 over 3. Now B, the appearance of number less than 3. Okay, I'm going to call this event B. So B equal set of number less than 3, which is 1, 2. Okay, probability of B equal here I have 1, 2 elements over 6, which is 1 over 3. So by looking carefully, the probability change every event into number. So this is the purpose of the probability, that I'm going to change the event or the expecting into a form of number. Okay, now the probability of number 4, the event C equal set 4. This is number 4. Okay, number 4 written in one phase only, so it is 1 over 6. The probability of appearance of number 7, I'm going to call this one D. Number 7 is not included in the sample space or in the dice, so it is phi. The probability in that case equals 0, because phi included 0 elements, over 6, which is 0. Now this is event E, the probability of appearance of number less than or equal to 6. So E equal 1, 2, 3, 4, 5, and 6. So it is equal 6 over 6 or equal 1. By looking carefully, I have now 3 types of the events. I have event A, event B, event C, all of them included between 0 and 1. All of them called possible events. And event D, this event equals 0, this is impossible event. And event E, this one equal 1, this is certain or sure event. Okay, the possible event, okay, may be occur and may be not. The impossible event, it's impossible to be occur. The certain event, it has to be occur. Okay, now let's complete this question. Number 6, the probability of appearance of a prime number. I'm going to call this one F. F included the prime numbers. Remember with me the prime numbers 2, 3, and 5. Okay, here I have 3 out of 6, which is 1 over 2. The next one, the probability of appearance of even prime number. Okay, the prime numbers are 2, 3, and 5. 2 is the even one, so G equal set of 2 only, it equal 1 out of 6. The probability of appearance of number divisible by 5. Number divisible by 5, okay, I have 1, 2, 3, 4, 5, 6. The only number can divisible by 5, it's 5. So this event, I'm going to call it H. H equal set of 5. Okay, so it is 1 out of 6 events. Now let's study some remarks. The first remark, the impossible event. The impossible event, okay, that the event that has no chance for occurring. Okay, again, event that has no chance for occurring, and it is equal phi, and its probability equal 0. Okay, so if he ask you the impossible event equal what, it is equal phi. The probability of the impossible event equal what? Equal 0. And the most common question is the probability of the impossible event, which is 0. Okay, Now the certain event is the event that has all possible outcomes and it is equal to the sample space. Again, event that has all possible outcomes and it is sure to be occur. Okay, for example, if we have an experiment flipping a coin and the event appearance of head or tail, so this is certain event because it's okay. The appearance must be head or tail, so this is a sure event. Another example, if we make an experiment and we flip or rolling the dice and the appearance of number from 1 to 6, it's okay, so the appearance must be from 1 to 6, so this is sure event. The probability of the certain event equal 1 equal 100%, so I can evaluate the certain event equal 1 or 100%. Any event as in general lie between 0 and 1. Okay, and because we studied the intervals in the first term, so I can say that P or possible event belongs to closed interval 0, 1. Okay, any event or any probability belong to the interval from 0 closed to 1 closed. So the least probability is 0, the maximum probability is 1, or any probability included between 0 and 1. Okay, or 100% of course. The sum of all probabilities of outcomes of a random experiment equal 1. What does it mean, Mr. Ahmed? For example, if we have a class, this class formed from boys and girls. If the boys equal 0.6, so the girls equal 0.4, because 0.6 plus 0.4 equal 1. So the sum of all probabilities must equal 1, and later I'm going to explain this point. Okay, now study the expected number, and this is a very important item in this year. Not all of time he will ask you find the probability. Sometimes he will give you the probability and he will ask you what is the expected number. Okay, the expected number of outcomes by using this magic triangle. Okay, here I'm going to write P, which is a probability. Here I'm going to write N, which is the number, and here I'm going to write total. Okay, the probability equal what? Probability equal number of event over total. Now if I need to evaluate the number of the expected number, it is equal probability times total. Okay, so this is the rule of the expected number. It's equal probability times the total number. For example, if the number of students in a class, okay, number of students in a class is 30, okay, and the student and the probability that the student wear glass is 0.1. Again, we have 30 students and the probability that this students wearing glass is 0.1. So if I need to evaluate the expected number of students who wearing glass, equal 0.1 equals the probability times the total. Probability times the total. Okay, again, probability number equal probability times total equal 0.1 times 30 equal 3 students. So this is a very important rule. Now let's solve example 2. Okay, in this example, a numbered card is selected randomly of a set of similar cards numbered from 1 to 24. Okay, I have a picture for you. Card numbered from 1 to 24 as you see. Okay, the first one, find the probability that the number carried, a multiple of 4. Remember with me, what are the multiple of 4? The multiple of 4 are any number divisible by 4. 4, 8, 12, 16, 20, and 24. 4, 8, 12, 16, 20, and 24. All these numbers divisible by 4, so they are called multiples of 4. Here the probability equal what? The probability equal 1, 2, 3, 4, 5, 6 over 24 equals 1 over 4. Another example, multiple of 6. Okay, what are the multiple of 6? They are 6, 12, 18, 24. They are the numbers in table 6. The probability here equal 1, 2, 3, 4 over 24, which is 1 over 6. Okay, multiple of 4 and 6 together. So I'm going to choose the intersection or the common between the two numbers. Here, 24 divisible by 4 and 24 divisible by 6. And also 12 divisible by 4 and also 12 divisible by 6. So the answer will be like this. The event set of 12 and 24. Here the probability equal 2 over 24 equals 1 over 12. Multiple of 4 or 6. Okay, there is a difference between and or. And means the common. Or means I'm going to take all of them. Or by another meaning, or means the union. So I'm going to take all numbers divisible by 4 plus all numbers divisible by 6 and write down the common one time only. So they are 4, 6, 8, 12, 16, 18, 20, 24. Here I'm took all the numbers inside this set and this set. Okay, but note that the 12 written one time only and the 24 written one time only. Now I have 1, 2, 3, 4, 5, 6, 7, 8. So the probability equals 8 out of 24 equals 1 over 3. Finally, number divisible by 25. I don't have any number divisible by 25 here, so the probability equal 0 and the event equal 5. Okay, but he asked me actually about the probability, not the event. Another example. Okay, drawing randomly colored marbles out of a box contains 12 red marbles, 18 white marbles, 20 blue marbles. Find the probability of selecting number 1 white marble. Okay, to write the event here, so I'm going to write set and inside the set white. Okay, so I will not write this event. I'm going to write the probability direct. P equal, here I have how many white? I have 18 white. Okay, I have 18 white. 18 out of the total 12 plus 18 plus 20 equal 50. Okay, so it is 18 over 50, which is 9 over 25. Another example, yellow marble. I don't have yellow, I have red, white and blue. So the probability here equal 0. This is what we said impossible event. red marble. I have 12 red marbles, so the probability here of the red marble equal 12 over 50. 12 over 50, which is 6 over 25. Red or blue? Red or blue, I'm going to take 12 red plus 20 blue. 12 plus 20 equal 32. So it's equal, the probability here equal 32 over 50, which is equal 16 over 25. Next. Not red. Not red, so I'm going to take white and blue. 50 plus 20, which is equal 38. So the probability here equal 38 over 50, which is 19 over 25. Example 5. Okay, example 4. In this example, garment factory in the 10th of Ramadan city produce 6,000 units daily. Okay, as a sample of 1,000 units we examined, okay, 20 defective units were found. Calculate the number of defective units. Okay, here the total production is 6,000. We took a sample, okay, and we study this sample. We found that 20 are defective or 20 are bad units. Okay, so I need to calculate the number. Okay, the number equal probability time total. So first I will evaluate the probability of the defective. Defective means bad units. Okay, now P between brackets defective or probability of defective equal a number of defective over the total number of the sample equal 1 over 50. Okay, now I need to evaluate the total number of defective but from the 6,000. Okay, the number equal probability times total. So it is equal 1 over 50 times 6,000 equals 120 units. Okay, another example, example 5. Here in this example, in a fruit packing plant, 30% of fruit is not suitable for exporting because the size is too small. How many tons can be exported in 10 days if 20 tons of fruits are delivered back daily to the factory? Okay, now I have the probability of the unsuitable part equal 30%. I have 30% is not suitable. Okay, so the percentage, this is the probability of the unsuitable part. Okay, now the probability of the suitable part equal 1 minus 30%, and 1, don't forget 1 is 100%. 100 minus 30 equal 70%. Okay, now I have the percentage of the good part of the suitable, or the suitable part is 70%. Okay, now I need to evaluate the total amount or the total tons in 10 days. I have 10 days. In each day I have 20 tons. So the total in 10 days equal 10 days times 20 tons equal to 100 tons. Okay, now I have the probability equal 70 and I have the total equal to hundreds. I can evaluate the number of suitable tons. The number of suitable tons equal probability times total equal 70% times 200. 70% in the calculator, 70 over 100 like this. 70 over 100 times 200 equals 140 tons. Okay, the next question. A calculator manufacturing company examined randomly electronic circuit, in a sample of 200 units. The defective production was 6%. How many units are out of order in this sample? Okay, now I have the total production is 200 units, or the sample equal to 100 units of the calculators. Okay, the defective or the bad units was 6%. So the number of out of order means the defective units or bad units. Okay, the number of bad units, but here I'm counting the bad units from this sample, equal 6% times 200s. Of course, 6%, 6 over 100 times 200s equal 12 units. So inside the 200 units, I have 12 are defective or 12 are bad. Okay, question number 2. If the total production in a month equal 1,500 units, this is a sample, but now this is the total production 1,500. How many units functional? Functional means good units, of marketing. Okay, first I'm going to evaluate the probability of functional. Equal, the probability of bad is 6%. So the probability of function is 1 minus 6%. 1 equal 100%. So 100% minus 6% equals 94%. Or 0.94. Okay, now the number of functional equal probability times total equal 94%. 94% means 94 over 100 times 1,500, which is equal 1,410 units. Okay. Example 7. Complete the following. The probability of occurring of impossible event equal 0, and the probability of occurring a certain event equal 1 or 100%. And also for every event the probability lie between enclosed set 0 and 1. The probability of occurring event equal 5 over 8, then the probability of doesn't occur equal 1 minus 5 over 8 equal 3 over 8. The probability that a person get infected in a city whose number of inhabitants is 20,000 with disease is 0.003, then the expected number of infected persons with disease in this city. Okay, now the total number in this city is 200,000, and the probability of the infected is 0.003. If I need to evaluate the number equal probability times total, which is equal 0.003 times 200,000, which is equal 600 persons. 600 persons. Okay, now example number 8. A bag contains number of similar balls. 5 of them are white and the rest are red. Okay, the probability of drawing red ball is 2 over 3, then the total number is, okay, now I have red, the probability of red equal 2 over 3. Okay, now I'm going to evaluate probability of white equal 1 minus, because the total probability equal 1, minus 2 over 3 equals 1 over 3. Now I have the probability of white and I have the number of white. Back to the magic triangle. Probability, number, total. Okay, number equal probability times total, and the probability equal number over total. But what if he asked me to evaluate the number? The number equal, the total equal number over probability. So the total number equal number of white divided the probability equals 5 divided 1 over 3 equals 15. Okay, and this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud.